Hello and welcome to another video. In this lesson, we're going to learn about the binary system or base 2. So, we're going to be learning about the binary system, or we can call it base 2. So, as we said, we're going to learn about addition. Let's how to add. We're going to learn subtraction. We're going to learn multiplication. We're going to learn division. And then we're finally going to learn how to convert to other bases. So we're going to learn conversion. So let's start with addition. Before we get into this other aspect, let's just do a basic introduction to the binary system. The binary system uses only two digits, which is 0 and 1. So what this means is basically you're only going to be seeing zeros and ones in the binary system. So you can see numbers like 1, 1, 1, 1. You can see numbers like 1, 0, 1, 1. You can see numbers like 1, 0, 0. You can see numbers like 1, 0. Now, to make a difference between 10 and 1 and 0 or 100 and 1 and 0, you always have to include the base. So this is base 2, this is base 2, this is base 2. Writing this lets us know what particular type of number you're trying to represent. Whenever a number is written on its own, like so if you have just 10 uh, without any base attached to it, this means base 10. So whenever you see a number that's just written like this means base 10. So whenever you're writing things in base 2, make sure you always include the base. So you must always write it as like this to be sure of the base we're talking about. Let's explain why. So if you write this like this means base 10. Base 10 is written, if we go ahead and express base 10, since it's base 10, we're going to have, let's see, this is the first number, so we have 0 and 1. So everything in base 10 is the power of 10 with this raised to the power of these numbers. So that means we'll have 1 times 10 to the power of 1 plus 0 times 10 to the power of 0. So this will be 0 and this will be 10. So we have 10 plus 0, which is still equal to 10. So this is 10 in base 10. But if you write this base 2 right here, so we have 10 base 2. We express this in base 2. You're going to see that the answer is going to be different. So for base 2, instead of 10, we're going to replace it with 2. So we have 0 and 1. So we have 1 times 2 to the power of 1 plus 0 times 2 to the power of 1. So we have 2 to the power of 1, which is 2. So we have 2 plus 0, which is 2. So this is 2 in base 10. So the expression of 10 to the power of 2 and just writing 10 are two completely different numbers. This is why you always have to include, the base you're representing. So now that we have that simple introduction, let's learn about the addition of binary numbers. So we're going to learn about addition. The addition of binary numbers is very much similar to the addition of your regular and decimal based system. The only difference is you always have to remember that in base 2 we're working with only zeros and 1. So for base 2 you cannot have 2, you cannot have 3, you cannot have any number that is not a 0 and a 1. So base 2 has some simple rules for addition. So for addition we have 0 plus 0, which is equal to 0. 0 plus 1 is equal to 1. 1 plus 1 is equal to 1 and 0, not 2. So writing 2 would be wrong. So it would be wrong for you to write 2. Then 1 plus 1 plus 1 is equal to 1 and 1. So you're going to write 1, and then you're going to carry 1. just like your basic addition principles. So let's solve some examples. If we have, so let's solve 1011 plus 1101. Both of them are in base 2. So let's go ahead and solve. So we're going to continue with your usual addition rules and regulations. So we have 1011, and then we have 1101. So we'll add 1 plus 1. Remember, 1 plus 1 is 1 and 0. So we're going to write the 0 and carry the 1. 1 and 1 is still 1 and 0. So we're going to write the 0 and we're carrying the 1. 1 and 1 is 1 and 0. So we're going to write 0 and carry the 1. And then 1, 1 and 1 is 1 and 1. I know there's a lot of strange numbers here, but just stick with me. We're going to have 1, and then we're going to carry the 1. So this would be the correct answer for this, the addition of this number and this number. Remember, always add your base 2. Remember our rules? Let's go ahead and rewrite our rules again. We said 1 plus 1 is equal to 1, 0. Here, we're going to write the 1. We're going to write 0 and carry 1. Then 1 plus 1 plus 1 is equal to 1 and 1. We're going to write the 1 and carry the 1. And then 1 plus 0 is equal to 1. So just try to remember these rules. So subtraction. The subtraction of binary numbers also has its own rules. So for subtraction, 0 minus 0 is equal to 0. 1 minus 0 is equal to 1. And then 1 minus 1 is equal to 0. And then when we have 0 minus 1, for here we're going to borrow 1 from the next column. So when you see something like this, you have to borrow 1 from the next column. So we have to borrow 1 from the next column. But remember, since this is base 2, remember this is base 2. So this is base 2. Whenever you borrow a number from the next column, the number automatically becomes the base. So as this is base 2, when you borrow 1, it's going to become 2 plus. I'm going to see an example. Let's have an example. If we have 1101 minus 1011 in base 2, let's go ahead and solve. So we have 1101 and we have 1011. So 1 minus 1 is 0. 0 minus 1, we're going to borrow 1 from the next, which is here. So this becomes 0. When we add that number here, it becomes 2. Remember, we are borrowing from the base. If this was base 10, we would have 10 plus 0. Since this is base 2, this number automatically becomes 2. So this becomes 2 minus 1, which is equal to 1. And then we have 0. And then 1 minus 1 is 0. So the final answer is just 1 and 0. And go ahead and cancel these two zeros. Now, it's possible for us to have 2 in this scenario because the final answer is going to be less than 2. And we're allowed to have 1 and zeros in base 2. So this will become base 2. We can solve another example. So if we have 1, 0, 0, 1, 1 minus 1, 0, 0, 1. So 1 and 0, 1 minus 1 is 0. This is 1, 0. This, we're going to borrow from here. So we have 2, and then we have 1. So this would be the correct answer for this minus this in base 2. Let's move on to binary multiplication. So multiplication. Binary multiplication is very much similar to decimal multiplication, but remember we can only use 0 and 1. So let's solve an example. Let's multiply 101 by 1 in base 2. So similar rules, so we're going to write this out, 101 multiplied by 1 and 1. So the same rules, just at the end of the day, you're still going to apply some additional rules when you're doing multiplication. So we have 1 multiplied by 1 is 1. 1 times 0 is 0. 1 times 1 is 1. Next, this, so we have 1 times 1, which is 1. 1 times 0, 0. 1 times 1 is 1. So we're going to add. So 1, 1, 1, and 1. So in base 2. This would be the correct answer for the multiplication of this and this in base 2. Multiplication of base 2 is very much similar to your base 10 or your decimal number. So just apply the rules. You're going to multiply this first, then multiply this, and then you're going to add the final answers. So let's do division, binary division. Let's learn about binary division. Binary division follows the long division method of your decimal system. So I'm going to make use of long division. One of the reasons why division and multiplication follow the rules of your decimal system is usually because whenever you divide numbers like 1 and 0 by 1 and 0, it's always going to be 1 and 0. That is why you don't really necessarily have to worry about seeing numbers like 2, 3, and 4. Because there is no way you're going to multiply 1 by 1 to get 2 or more than. And there's no way you're going to divide 1 by 1 or 0 to get any of these numbers. That is why it's always much similar to your decimal system because it just follows a straight rule. So let's solve an example. So let's divide 1, 1, 0, 1, 1 in base 2 by 1 and 1 in base 2. So following our long division rule, this would be 1 and 1. I think we have 1, 1, 0, 1, 1. So if we go ahead and divide this by this, we have 1. If we multiply, we have 1 and 1. Then we're going to subtract, following your long division rule. So we're going to have, this is going to be 0 and 0. So we have 0. The next number here is, 0. So if we go ahead and divide, since we have two-digit numbers here, go ahead and divide. This is still going to be 0. So if we multiply, we're going to have, we're going to still have 0. We're going to bring down this 1 next. So we have a 0 and a 1. And if we divide this 0 and 1 by this, the answer is still going to be 0. So if we multiply again, we have two zeros. That means this, if we're going to subtract, that means we have 0 and 1. So that means we have 1 here. Then we're going to bring down this 1 right here. So this final 1, we're going to bring this down. So this divided by this is 1. Multiply, we have 1 and 1. Subtract, this is will be equal to 0. So when we divide this by this, the answer is 1001 in base 2. Let's do another example. We have 110, and then we have 101101. This is a three-digit number, so we're going to start first with three-digit numbers. This will not be possible to divide because this is greater than this, so we're going to move to the fourth number. This can divide, so we have 1. If we go ahead and multiply, we have 0, 1, 1. So we're going to subtract. So if we subtract, and so we'll have 1, 0, and 1. This again cannot divide, so we're going to bring down this next zero. So we have 1 0 1 0. We divide this, we have 1. We go ahead and multiply again, so we have 0 1 1. So we're going to subtract again, so we have 0 0 and 1. Then we bring down this number here. So we have 1 0, this final number here. So we have 1 0 and 1. We divide, we have 1. Go ahead and multiply, we have 0 1 and 1. So if we subtract, we're going to have 1 and 1. So since this cannot divide, we're going to just stop here. So the final answer would then be equal to 1 1 1 base 2. Another way to check for your division, another way to divide if you have issues with long division, is to convert these numbers, to base 10, solve the answer, and then convert the answer back to base 2. Let's see how this will play out. So this will now lead us to conversion in binary. So to convert from base 2, so going from base 2 to base 10, we're going to multiply. So from base 2 to base 10 is multiplication. So you multiply. Then going back from base 10, so from base 10 to base 2, we'll divide. I'm going to see what this means soon. So we're going to divide. So for example, in our first example, we had 1 1 0 1 1 divided by 1 and 1 in base 2. So we're going to multiply. We're going to multiply each of this. So remember that we said in base 2, each position in a binary number represents a power of 2 starting from 0 on the right. That means each of this is multiplied by a power of 2 starting from here. So we have 0, 1, 2, 3, and 4. Starting from here. So that means we're going to have 1 plus 2 to the power of, 1 times 2 to the power of 4 plus 1 times 2 to the power of 3. So this is just, 1 and 0. Let's go ahead and skip with the multiplication and all. This would be 0, we'll have plus 2 to the power of 1 and plus 2 to the power of 0. So 2 to the power of 4 is 16. So we have 16 plus 8 plus 0 plus 2 plus 1. So if we go ahead and add this together, we have 16 plus 16 plus 11. This will be equal to 27 in base 10. Let's do for 1 and 1. So this will be 2 to the power of 1 plus 2 to the power of 0. So this would be 2 plus 1. So this is 3. If we go ahead and divide, we have 27 divided by 3, which is equal to 9. This is 9 in base 10. Now we're going to convert this 9 back to base 2 to verify our answer. Remember, when we're converting from base 10 to base 2, we're going to divide. What it simply means you're going to be dividing by 2 until you reach 0. So this would be 9 divided by 2. We're going to keep the remainders if there's a remainder. If there's no remainder, there's always a remainder of 0. This will be equal to 4 remainder 1. We're going to continue dividing this number. We're going to forget about the remainder. So we have 4 divided by 2 is equal to 2, remainder 0. Then we have 2 divided by 2 is equal to 1, remainder 0. Continuing from this one, we have 1 divided by 2 is equal to 0, remainder 1. Then we're going to start arranging the numbers. Let's make some space here. We're going to now start arranging these numbers from here to here. So this will be equal to 1, 0, 0, 1 in base 2. So from our previous answer, when we solved before, our answer was 1, 0, 0, 1 in base 2. If I forgot to just rewind the video and check. So we have 1, 0, 0, 1 base 2. This is also another way you can solve, division in binary. If you have issues with long division, so if I forget about long division, this may take time depending on your speed level. So you can put this in mind for solving of division in binary. Let's look at other example. Remember what we said? Conversion of base 2 to base 10 is multiplication, and conversion of base 10 to base 2 is division. Let's look at the other example. For other example, we had 1, 0, 1, 1, 0, 1 divided by 1, 1, 0. So we're going to convert both of these to base 10. So for this, we have 0, 1, 2, 3, 4, and 5. So we have 2 to the power of 5 plus 0 plus 2 to the power of 3 plus 2 to the power of 2 plus 0 plus 2 to the power of 1. The reason why I'm using 0 because any number multiplied by 0 is 0. So there's no point in calculating and then multiplying by 0. So 2 to the power of 5 this will be 32 plus 0 plus 8 plus 4 plus 0 plus 2. So this is supposed to be 2 to the power of 0, so this will be plus 1, because any number to the power of 0 is 1. So I'm going to add this, so that would be 45. So this will be equal to 45 in base 10. So for this, we have 2, let's say 0, 1, and 2. So 2 to the power of 2 plus 2 to the power of 1 plus 0. So we have 4 plus 2, which is equal to 6. So I'm going to divide 45 in base 10 by 6 in base 10. So we have 45 divided by 6. So we have 7.5, but we're going to approximate this to just 7. So be equal to 7. Then we're going to convert this 7 in base 10 back to binary. So to convert to binary, we have 7 divided by 2, which is equal to 3, remainder 1. 3 divided by 2 is equal to 1, remainder 1. Then 1 divided by 2 is equal to 0, remainder 1. So starting from here to the top, we have 1, 1, 1 in base. So this will be equal to 1, 1, 1 in base 2. So you can go ahead and rewind and check. Our answer from our long division is 1, 1, 1 in base 2. So this is another easy way. It's a bit stressful, but it's less confusing because your long division has a lot of rules. You're going to divide, you're going to multiply, you're going to then add. So if that one is confusing you, you can always make use of this. Always remember, whenever you divide, there is a remainder. You're going to just ignore that remainder and work with the whole number. So I think we've covered everything on binary. So I've learned about addition, I've learned about subtraction, I've learned about multiplication, division, I've learned about conversion. Conversion can help you in any of them. So whenever you're confused with your addition, multiplication, your subtraction or whatever, you can always convert to base 10, solve, and then convert back to whatever binary, whatever base you're working with, whether it's base 1, 2, 3, or whatever. Let's look at some of the applications of binary. So binary numbers are the foundation of computing and digital systems. They are used for programming, data storage, and even your modern electronics like computers. That's it for this lesson on binary system. We have covered addition, subtraction, multiplication, and division in base 2. If you found this video helpful, don't forget to give it a thumbs up, share it with your friends, and subscribe for more educational content. See you in the next video where we'll possibly discuss other types of number-based systems like base 10, base 8, and base 16.